We've seen that if you want to draw reasonable, plausible Lewis structures, our best bet is to follow the octet/duet rule and to draw structures where the atoms have zero formal charges. Now, the most common atoms you encounter are hydrogen, carbon, nitrogen, and oxygen uh, when drawing structures of molecules. So let's be familiar with the way these atoms can achieve a zero formal charge in a structure. Hydrogen is pretty simple. We've already seen this before. Hydrogen has to be a terminal atom. Terminal atom. It can only form one single bond. And whenever it does that, okay, it has a zero formal charge. Why? Because by itself, hydrogen would have one electron, okay? And so if it forms a single bond, so a free atom of hydrogen would have one electron, and it forms a single bond, half of that single bond would be one electron, so it would appear to own one electron in the structure if it has a single bond, so your formal charge is going to be zero. What about carbon? In general, for other atoms, if you have x valence electrons, then you can get a zero formal charge if this atom is surrounded by an octet by having 8 minus x bonding pairs. So for example, carbon, okay, 8 minus 4 is 4. So that means if carbon has 4 bonding pairs and it's surrounded by an octet, it has a zero formal charge. So the typical pattern that you'll see for molecules that have carbon, most of those molecules will have carbon either with 4 single bonds around it, so that's 4 bonding pairs. Or you can have a carbon with 2 double bonds around it. That would also have 4 bonding pairs. That's a zero formal charge on that carbon. Or you can have a triple and a single. Okay, so that's still 4 bonding pairs. Or you can have a double and 2 singles for carbon. So those are the typical bonding patterns for carbon. So it's quite a versatile atom as far as being able to link up with other atoms. Okay. Now, nitrogen, in order for nitrogen to have a zero formal charge, okay, so by itself, a free nitrogen atom has 5, right? 1, 2, 3, 4, 5. So by itself, it has 5. So it would, if it owns half of this pair, half of this pair, and half of that pair, so that means if it forms 3 bonding pairs, 8 minus 5 is 3. If it can form 3 bonding pairs, then it will have a zero formal charge. So 3 bonding pairs, and it has a lone pair all to itself. So, okay, so 5 minus 5 would be 0. So nitrogen, the typical bonding patterns for nitrogen is you have a lone pair and 3 single bonds, like for example in ammonia, okay, or in hydrazine. See, this nitrogen has 1, 2, 3 bonding pairs and a lone pair. This nitrogen over here has 1, 2, 3 bonding pairs and a lone pair. Or instead of 3 single bonds, a nitrogen can also have a double bond and a single bond and a lone pair. So that's 3 bonding pairs and a lone pair. Or it can have a triple bond and a lone pair. Okay? So that's 3 bonding pairs in a lone pair. An example of this one right here would be something like this one right here, nitrous acid. So this nitrogen right here has a zero formal charge. An example of this one, you've seen something like this before, earlier in an earlier lesson. You have HCN. So this nitrogen right here has a triple bond and a lone pair. This hydrogen cyanide, that has a zero formal charge. Okay. Now, it is quite common to find nitrogen with a +1 formal charge. So how can a nitrogen have a +1 formal charge? That's when it forms 4 bonding pairs and it doesn't have a lone pairs. So here, if it has 4 bonding pairs, it appears to own 4. A free nitrogen atom would have 5. So 5 minus 4 would give you a formal charge of +1. So that's quite common for nitrogen, actually. All right. What about oxygen? Oxygen, you can get zero formal charge if it has two bonding pairs and two lone pairs, because if you subtract, okay, 8 minus 6, this is the number of free valence electrons that a free oxygen atom has by itself. So 8 minus 6 would be 2, so that means two bonding pairs. Okay, so oxygen can have two lone pairs and two bonding pairs. See, if it owns 2, 4, 5, and 6, then it would have a zero formal charge. So the bonding patterns you'll find for oxygen would be, it either has two single bonds and two lone pairs. For example, in water, okay, it has two single bonds and two lone pairs, or it can do a double bond. So for example, O2 molecule would have a double bond and two lone pairs. So the bonding pattern for oxygen is two single bonds and two lone pairs, or double bond and two lone pairs. Okay, now sulfur is right below oxygen, so you'd think sulfur would behave similarly. Nitrogen and phosphorus are in the same column, so you have similar behavior. And carbon, below carbon, you have silicon, you have a similar behavior. Okay, now oxygen, you do need to be aware, also has a tendency to have a negative one formal charge, and it can do that by having three lone pairs and a single bond. Okay, in this case, it will have a negative one formal charge. Why? That's 6 electrons. It would appear here to own 6 electrons from the lone pairs plus 1 from the bonding pair. That's 7. A free atom of oxygen owns 6, so 6 minus 7 is negative 1. So a negative 1 formal charge for oxygen is quite common. That would suggest an oxygen with a single bond and 3 lone pairs. Okay? Oxygen can also have a plus 1 formal charge. That would mean that happens when it has 3 single bonds and a lone pair. Because now, for example, in hydronium ion, that's what it will have. It will have a positive formal charge. Why? Because oxygen by itself would own 6, and in this structure, if it has 3 single bonds, that's 3 plus 2 in the lone pair, it would appear to own 3 from the bonding pairs plus 2 from the lone pair. 6 minus 5 would be plus 1. Okay, so if an oxygen has 3 bonding pairs and a lone pair, it has a plus 1 formal charge. By the way, hydronium, you can write it that way, or you can write it with the brackets. So you can, if you indicate the formal charge, that you don't have to put it in brackets.